Hello everyone, welcome to Python learning series. In this video, we'll see what is UV Python package manager, how to install and use UV for your projects. UV is a high performance Python package manager. It aims to be a replacement for our traditional package managers like pip-tools, venv, virtualenv, etc. And these are some of the advantages of UV: very fast installation and dependency resolution, and one tool can handle installing, locking, and syncing the dependencies. It is fully compatible with requirements.txt or pyproject.toml file. We'll see how to use all those, and no need for pip freeze feature. And it is having built-in virtual environment manager, and lock file generation is like pip-tools, and it supports all these platforms: Windows, Linux, and macOS. Now we'll go through the documentation and see how to install that. I'll go to introduction. Here we can see an extremely fast Python package and project manager written in Rust. It is developed by Astral, and you can see the time taken by UV and other package managers. A single tool to replace pip-tools, pipex, or many other Python package manager. And if you want to install that, now we'll go to getting started, installing UV. Installation step is very simple. I'm using macOS, so I can use Homebrew for installing this. I'll copy this command. I'll go to the terminal, paste it. I have already installed it. So I'm using 0.7.11. For all the operating systems, you can see the documentation here. For the demonstration, I'll be using this particular directory, uv_tutorial. We'll talk about even this script. Now I'll go to VS Code. I'll open the directory, UV tutorial. Click on open. So we'll talk about this particular file. For this example, I have just added a very simple script which just executes a command on Cisco device and gets the output. I have added this because we want to see how to handle the library dependencies here. This code is not mandatory. You can even simply give this import and test this code. Additionally, I have added the code for getting the Python environment details. For that, I'm using import lib metadata. From there, this will be giving us all the packages available in the Python executor. Then this will be printing Python version, then the Python implementation, then the executable path and platform. So this is mainly for getting the Python details, and this is just to check the library dependency. First, I'll show how we do in a traditional way. We'll create a directory. I'll call this with venv. Open terminal. I'll move this code to with venv directory. Now we'll try running this code with venv python 3, then get show run. And here we can see the error module not found because currently it is using the default Python version in this operating system. It is in library frameworks, Python frameworks folder, and by default it is having only these two libraries. Now let me just create a virtual environment here, python 3 -m venv, and within this particular directory I will create a folder called .venv. Now if you notice here, it has created the virtual environment. Now I need to give source .venv bin activate. And now if I run this script, the executable path has changed to this directory, and Python version is 3.12.7. Now here I'll install pip install. Let me go. And previously this was having only this package available, and this print is coming from this section. Now let me run the script again. So now we have all these dependencies installed. Now it is trying to connect to the device and getting the output. Now from here, if you want to get all the requirements in a requirements.txt file, what we can do is we can do pip freeze and put it into requirements.txt. So now we have a requirements.txt file. Now if you want to replicate this requirements, what we can do is we can do pip install -r and requirements. So like this, you can replicate the same environment in another system. Now we'll see how to do this with UV. I'll create a directory. I will call this with UV. I'll get into that directory underscore UV. And first command is to initialize a project. We'll go to the documentation, go to the features. Here, if you want to handle the Python versions, to list the versions, we can use Python list. To install a specific version, we can give UV Python install. Let me first show you that command. Here I'll give UV Python list 3.12.11 download is available, but first without that we'll try running this. I'm inside this directory and this directory is empty now. I'll give UV init, enter, and by default it has added certain files. Git ignore, this is by default ignoring this .venv file, so that when you are pushing this code to GitHub, it will ignore all these virtual environment files. Then current Python version is 3.10. It is pulling from the system, and there is a sample main file available. You can just remove it. It is not mandatory to have this file. Then we have pyproject.toml file. It is very important to understand this file. Now we'll go to the documentation. Under projects, structure and files, here we can see Python project metadata is defined in a pyproject.toml file. UV requires this file to identify the root directory of a project. So pyproject.toml file is used to define the specific Python project metadata. It actually replaces our traditional setup.py, setup.cfg or requirements.txt file. You can add your dependencies also there. Here currently it is empty. If you want to add any dependencies, you can just do uv add that particular package name and it will automatically add the dependencies here. Now if you click on this particular link, so it will be taking us to the official Python packaging documentation, and UV is following same standard. You can add all these details into your pyproject.toml file, and the extension toml stands for Tom's obvious minimal language. Originally it was called Tom's own markup language. It is developed by Tom Preston Werner in 2013, and it is intended to be easy to read and write due to obvious semantics which aim to be minimal. And TOML's syntax primarily consists of key value pairs. And if you look into the file, it consists of key value pairs only. Now, from this particular documentation, we will try to add additional data. I'll try to add the author information. I'll copy this. It is not mandatory to add it. You can just add if it is necessary. So I'm just giving a fake email address. Now, if you want to add a description for your project, we can add it here. This is a UV demo project. And current Python version is 3.10, and that version we can see here also. Now from here, I'll copy this showrun file, add it into UV project. For running any Python file, we need to use UV run, and we can see that even in the documentation under features, we can use UV run for running a Python script. So I'll give UV run get. Now we'll be getting the netmiko error. We haven't installed the dependency. But if you notice here, now the executable path has changed to this directory with UV. But Python version is 3.10.17. And now if you want to install a particular Python version, or if you want to check a version availability in the machine, we can give UV Python list. See, this particular version download is available. If you want to install it, we can just give UV Python install 3.12.11. Okay, now it has installed this package. Now if I give UV Python list, so this version is available. Now if you want to change to 3.12.11, we can go to Python version, change the version here 12.11, and in the pyproject.toml file we can give 12.11, or we can even give 12. We'll give 3.12, and now we'll even add the netmiko library. For adding the library, we can give UV add netmiko, enter. So now you can see here it is using C Python 3.12.11. Now let us try running the script. UV run get show run, and now the Python is 3.12.11, and you can see the location. It is with uv.venv bin python 3. So like this, you can easily install the Python versions or packages. Now, if you want to install a specific version of a library, we can do uv add request equal to 2. We'll install a specific version 2.31.0. We need to be equal to enter. So now if you notice here, it has installed all the dependencies as well. Now if you want to see the dependency structure, we can give uv tree, and all these packages have installed as part of netmiko requirement, and these packages came as part of request library. And if you notice here, now it has created a uv.lock file. We'll go to the documentation and see what is that. Projects, structure and files, the lock file. So UV creates a uv.lock file next to the pyproject.toml file. This is a universal or cross-platform log file that captures the packages that we would be installed across all possible Python makers, such as operating system architecture and Python version. And pyproject.toml is used to specify the broad requirement of your project, but log file contains exact resolved versions. If you see here, this contains all the exact versions of the dependencies, and this file should be checked into the version control. If you are committing your code to GitHub, you need to even include your log file. From the log file also others can install all the packages. So you need to copy pyproject.toml and log file. Now from here, if we try to uninstall request, uv remove request, so it will be automatically removing all the dependencies as well. Now I'll give uv tree, and now we have only netmiko and its dependencies. But in case of venv, we were getting a plain text file which contains all the dependencies. And if you try uninstalling netmiko, it will be removing only this particular package. Now if I want to install the latest version of request, uv add request, so now it will be adding the latest version of request library, and accordingly it will be even updating the log file. Now imagine you want to transfer all these files and dependencies to another directory. So I'll just create a directory here with uv2. I'll copy this. These files are not mandatory, git ignore and all, but we'll just copy it. Our actual file by project and uv.log file and readme file. Copy it. I'll paste it here. Now I'll go to uv2 directory with uv2. Now we don't have .venv directory here, but I'll just run the file uv run get showrun.py. So it automatically created the environment, added all the dependencies. Script is running. So in this way, you can easily maintain all the dependency packages. And now here also, if we give uv tree, we will be able to see the structure. Now, if you want to add these requirements to UV project, but once you add it, what will happen? This particular hierarchy will go, all these dependency tree. I'll show you that. I'll just paste it here. So previously we were getting this hierarchy. Now uv add -r requirements.txt. Okay, now we'll check uv tree. Now if you notice here, it is not maintaining the previous hierarchy, and under netmiko we have few libraries, and ntc templates and all become separate library. Even if you remove netmiko, it won't be removing all the other dependencies. For example, if I do uv remove netmiko, it has removed only the netmiko library. We can check that in the pyproject.toml file. Here we can see even under this also it is adding all the dependencies. Now if you want to change it, we just need to copy these files, delete it and paste it. Now we'll run it again. So now we have the proper hierarchy. So in this video, we have seen how to use Python venv for creating the virtual environment, then how to install UV and initialize a project, and what is pyproject.toml file, uv.lock file, how to transfer this to different location, and how to install all the dependency packages. I hope this video was helpful. Thanks for watching. See you in the next video.